guys, welcome to Mrs. Mitchell's Reverse Classroom. Yesterday in class we talked about solving one-step equations, and we did those one-step equations doing the inverse operation of addition or subtraction. Well, today we're going to be talking about one-step equations doing the inverse of multiplication or division. Remember, the multiplication and division property of equality says if you multiply or divide each side of an equation by the same non-zero number, then the two sides are going to remain equal. You know it as the golden rule of algebra. Whatever you do to one side of an equation, you must do to the other. Now, what we're trying to do is to isolate our variable. We want to get an example 1a isolated by itself. So in order to undo multiplication, the inverse operation of multiplication is going to be division. So we're going to divide by -3 in order to isolate a to get a by itself. But the golden rule says whatever you do to one side, we must do to the other. So we have to also divide 15 by -3 in order to keep our equation equal. So reviewing our multiplying and dividing integers, a positive number divided by a negative number. That's that positive negative face, if you remember that. Tells us that it's going to end up being a -5. Now, if you read your instructions like you should, they're asking us to check our solution. We're checking to see if -5 really does give us 15 if we plug it in for a. So over here to the right, I want you to do your check. So we say -3 times -5. Now it's the opposite face. Negative times negative makes us happy, makes us positive, we're asleep. And negative times negative is going to make us a positive 15, which is what we're checking to see. Is it going to make 15? And 15 does equal 15. It's supposed to be a question mark right there. And I always like to say, cha-ching, it checks out. I know I have my answer correct. I can circle it with confidence. That is the answer to example number 1. All right, moving on to example 2. We have a -x. I need to undo. It looks like it's being multiplied by an understood -1. So if I divide by -1, that'll undo the -x. But I have to also do the same thing to both sides of the equation. And so negative divided by negative makes positive. And a +5 divided by a -1 is going to make a -5. So now I'm going to take that and do my check over to the right. -5 in place of x. And x was negative. So negative, negative, does that make a +5? That's the question. And that is going to give us 5 equals 5. Cha-ching. That one's going to check out also. All right, I'm going to be quiet for just a minute and let you try example 3 before I start working. We need to undo the multiplication. (28) divided by 7 is 4. Now we're going to check to make sure 7 times 4, does that equal 28? It does. Now we're ready to do number 4. Up, the m jumped over to the other side. It's okay. We still need to undo multiplication here, so we're still dividing both sides by -8. That cancels and gives us 1m. And a positive divided by negative, that's going to give me a negative answer. 24 divided by 8 is going to be 3. So check it over here. 24, does that equal -8 times -3? Negative, negative makes positive. It is going to check out. So I can confidently circle my -3. I forgot to circle my r equals 4 and my x equals -5. And I like to be able to find your answers, so please go back and circle those. Okay, so it looks like most of our example problems here, we're going to be dividing because the variable is being multiplied. So to undo multiplication, you're going to do division. If we scroll on down, or you turn over your paper to the back, here's some division problems. Number 15, -1 equals n divided by 4. So what is going to be the inverse of division? It's going to be multiplication. So we need to multiply. Be careful, that's a -1 that we're going to multiply times 4. So 4 times -1 is -4. And what happens here, 4 is understood to be over 1, and 4 over 4 cancels out to be 1, and that leaves us with 1n. So we need to check to see if for sure when we plug in -4 we're going to get -1. So let's check it. -1, does that equal -4 divided by 4? As I mentioned here, a 4 over 4 becomes 1. So -1 equals -1, cha-ching. It does check out, so we can confidently circle that n is -4. Number 16, it is division. So to undo division, I need to do multiplication. Oh, we're multiplying times 0. Anything times 0 is 0. Then on this side, this is a 7 understood over 1. And the 7 cancels, and h equals 0. Now let's check it. 0 over 7, does that equal 0? Well, remember our house? We talked about as long as you have a foundation on the bottom, you can have 0 on top. I even tried to draw a Bricko block one day for you, trying to make it look like a foundation. That will exist. If you have a foundation, even if you never build a house, your foundation is going to exist. It's the opposite. You cannot have a house on top of no foundation. That one is not going to exist. So this exists, and 0 equals 0, so it does check out. Because the question is 7 times what equals 0? Well, 7 times 0 equals 0. So h is 0 in that problem. All right, why don't I let you try 17? I'll be quiet for just a minute. I hope you realize you need to be multiplying since it's a division problem. Multiplying times -2. -2. Trying to get that -2 to cancel out and give us a. Negative times negative, that's when we're asleep and we're happy, it's going to make us positive. So that's going to be a +2. Now we're going to check it. +2 divided by -2, does that equal -1? Well, the 2's cancel and make it understood 1, and it's negative, so -1 does equal -1, and so it does check out. I can confidently circle that A equals 2. Now I know you're going to get tired of always checking, but trust me, when it's test time, you can turn in your paper and already know you made a 100 before I ever even start grading it. All right, believe it or not, I've only been talking for a little over 9 minutes. So I'm going to move on down here to some word problems so that we can have a few of those to practice together. Johnny has $55 in his savings account. This is $21 more than David has. Write and solve an equation to find the amount David has in his savings account. We talked yesterday about the fact you could probably figure out this problem without making an algebraic equation, but we're going to practice making algebraic equations while it's easy so that we're in the habit and getting used to the idea of writing an equation, so when the problems get more complicated, we will know how to do this. All right, so Johnny has $55 in his savings account. This is $21 more than David. I'm going to give D of the variable for guess who? For David. For David's account, his savings account. So David's account is D. Write an equation to find the amount that David has. So that's what we're looking for. We're looking for David's amount in his account. And Johnny's is $21 more than David's. So I'm going to take David and I'm going to add $21 to it and say that that equals 55. Because whatever David had, you add 21 to get Johnny because he had 21 more than David. And there it's a real simple addition problem where we have to do the inverse of addition, which is subtraction. So we would subtract 21 from both sides of the equation, and that will cancel. And D equals, when I do my subtraction here, I get 34. That's the amount of money that David had in his account, $34. All right, you try the next one. Okay, the temperature fell 16 degrees between noon and 3 p.m. At 3, the temperature was -3 degrees. Write and solve an equation to determine the temperature at noon. So at noon, we don't know what the temperature was. So I'm going to let it N equal noon's temp. Okay? And it fell 16 degrees. So I don't know what the temperature was at noon, but it went down, so it was -16 degrees. It fell, meaning it went negative. So -16 equals, and then at 3, it was -3 degrees. So I need to figure out what the temperature was at noon that made it -3 after it dropped 16 degrees. So the inverse operation of subtraction is addition. I'm going to add 16 to both sides. And that tells me that N equals a positive, because remember those adding and subtracting integers, there's opposite signs, so we subtract and keep the sign of the larger absolute value. And the absolute value of 16 is bigger than the absolute value of -3. So we subtract and we'll get 13. So if it was 13 degrees at noon, you can check that, plug it back in. 13 minus 16, does that equal -3? And it sure will, because we have opposite signs, so we subtract and get 3 and keep the sign of the larger, and -3 equals -3. It checks out. I can confidently circle that N is 13. And I know I've got that problem right before I turn my paper in. Okay, so the problems that we didn't work together on this session, you need to finish for homework. Give me your best attempt. And at the bottom right-hand corner of your page, just tell me if you enjoyed our reverse classroom, if you thought this was a fun way to learn a new concept. Just give me a yes or a no down here in the bottom right-hand corner. Thanks so much and have a great day.